Good morning.
Good morning.
All right. Let's see. So, is everyone there in Holbrook?
Not really.
She's not feeling well today. Let's see. All right. And let's see. So Avery's not there?
He's just late like always.
All right. Let's see. Is Miss Buckley there?
Yeah, she is.
I'm here.
Okay. So, Miss Buckley, I know it's.
Yeah. I've had the discussion with him.
Oh, okay. That's all right. I'll just tell Avery directly, okay? So Avery, when I'm taking roll, I need you to be in class. Otherwise, I'm going to have to start marking you tardy, okay?
Okay, sounds good.
All right, thanks. There's a part of me that doesn't even believe in tardies, but it is what it is. So we'll just deal with it. Okay, so today we are going to continue on with 6.2 and the trig functions of any angle. And I don't know if we'll be able to finish that or not. Tomorrow during class time, we will have our first quiz on 6.1. And again, it's going to be you'll have 5 questions. You will get your highest score on the 2 attempts. So we're going to try that and see how that works. Even if we finish 6.2 today, you're not going to have a quiz on that tomorrow. So it's just the one section. Okay. Let's see what else. Oh, and then also if you have, if you want to opt out of the quiz tomorrow and go to tutoring, you always have that option, and then you just work out with your talent aid and me as far as when you want to take the quiz. Okay. So it's totally up to you. So we'll just see how that goes. All right. Well, so let's go ahead and get started on part 2. All right. So we're going to be talking about the special triangles here, first of all. So hopefully the special triangles that we're talking about, that you are familiar with these from geometry. If not, this is going to be one of the things that I'm going to want you to focus on right away, because really throughout, even in calculus, we were talking about the special triangles. So you're going to need them. So let's start with that. Okay, so all right, so it says construct a right triangle having 45 degrees as one of its acute angles. All right, so even on the side of your paper, somewhere there's a blank or whatever, you can go ahead and draw a triangle, a right triangle that has 45 degree angle. So you know that the other acute angle is what? What would be the measure of the other acute angle?
It would also be 45, right?
And how do you know that?
Because all the sides all the angles add up to 180.
Yes, very good. Very good. So the other side has to be 45 degrees. Okay, so you'll want to label that on your paper. Okay, now it says choose one as the length of the adjacent side. So one of the legs. So now what do we call triangles that have two angles the same and two sides the same?
Isosceles.
Isosceles. So the triangle is isosceles. So if one leg has a length of 1, the other length, the leg length is also 1. Okay? And now if you know two sides of a right triangle, how do you determine the third side?
Pythagorean.
Pythagorean theorem. So using the Pythagorean theorem, the length of the hypotenuse would be what? So if you have sides of 1 and 1, what would be the length of the hypotenuse? The longest side.
Radical 2.
Yeah, square root of 2. Not 2, because remember it's a squared plus b squared equals c squared. So 1 squared plus 1 squared would be 2. So if 2 is c squared, then c would be radical 2. So the length of the hypotenuse is the square root of 2. Okay? So, so you should have this or something like it on your paper. If you don't, go ahead and draw that on your paper. Okay. All right. Now, so when we're trying to do the 6 trig functions for this special triangle, then we get the sine of 45 degrees. Well, you might say, well, which 45 do we go from? It doesn't matter. Okay? So the sine is opposite over hypotenuse, so 1 over radical 2. Now, sometimes you'll see me write it like this, 1 over radical 2. If we rationalize the denominator, then and multiply top and bottom by radical 2, then that becomes radical 2 over 2. And sometimes you'll see me write it like this, but it means the same thing. It's just radical 2 over 2 is rationalized, okay? But it's easier to think of it like this, 1 over radical 2, when you're figuring out the cosecant. So what would the cosecant of 45 degrees be?
Radical 2.
Radical 2. Because it's the reciprocal of 1 over radical 2. So it would just be radical 2 over 1 or radical 2. All right, then the cosine of 45 degrees, adjacent over hypotenuse. So 1 over radical 2, well, it's the same thing because the opposite and the adjacent side are the same. So 1 over radical 2, or radical 2 over 2. So then the secant of 45 degrees would just be radical 2. All right, and then the tangent of 45 degrees is going to be opposite over adjacent, so 1 over 1, which is just 1. So then the cotangent of 45 degrees is also 1. Okay? Yeah. Yeah, if you're going to hold up your finger for the answers, that's great, but just make sure it's not the middle one. Okay? Thank you. Yeah, so 1 would be the correct answer. Okay? So, all right. Any questions on that? All right. So now let's do, oops. So now let's talk about the other special triangle, the 30, 60, 90 triangle. Okay, so now, draw somewhere on your paper a right triangle having 30 degrees as one of its acute angles. Okay? So by the same logic, Jay, the third angle would be
60.
60. So you have 30, 60, 90. I actually said that, didn't I? So 30-degree angle, and then you have your right angle, and so the third angle would be 60 degrees. Because, like Jay said earlier, all the angles have to add up to 180. All right, so now choose one as the length of the shortest side. So the shortest side has to be opposite which angle?
The 30-degree angle?
Yes, because the shortest side has to be opposite the smallest angle. So choose one as the length of the shortest side. Okay, so does anyone know what the length of the other leg would be? Anybody remember from geometry?
Radical 3?
Radical 3. See, we actually talked about this the other day. So radical 3, and then once again, using the Pythagorean theorem, the length of the hypotenuse would be 2. Okay? So we talked about these triangles the other day, but and getting the ratios down. And then, but now we're coming back to them and defining our trig functions for those. And you have to know these. You're going to have to know what the sine of 30 degrees is. And so the first way, or one way that you can learn that, is make sure you know those triangles. If you can reproduce those triangles, you're going to be just fine. Okay? All right. So here's our triangle here. 30, 60, 90. So the side opposite the 30 degrees is 1. The other leg is radical 3, and then the hypotenuse is 2. Okay? All right, so now if I say, what's the sine of 60 degrees? Well, once you have the triangle, see, then you can do that. So remember, the sine is opposite over hypotenuse. So it would be radical 3 over 2. Okay, so the sine of 60 degrees is radical 3 over 2. The cosine of 60 degrees would be adjacent over hypotenuse. So that would be 1 over radical 2. Okay, the sine of 30 degrees. The sine of 30 degrees. So the opposite from the 30-degree angle is 1 over 2. Well, wait a minute. So is the sine of 30 the same as the cosine of 60? Yeah, because the side that's adjacent to the 60-degree angle is the one here is the same as the opposite of the 30-degree angle. So the cosine of 30 and the sine of 60 are also the same. Radical 3 over 2. All right?
Professor Strong,
Yes.
is the bottom right angle always going to be the 60-degree angle?
No, you can have your triangle drawn differently. It just, when you're doing the trig function, you have to make sure that you're coming from the right angle. So you got to make sure it's labeled correctly. So the 30-degree angle is always opposite the shorter side, the 1. Okay? All right, now, so the tangent of 60, so the tangent, we would go opposite over adjacent, TOA. So radical 3 over 1, which would just be radical 3. Whereas the tangent of 30, see, you come from this angle, so opposite over adjacent, it would be 1 over radical 3. Okay? So again, you got to make sure you're coming from the right angle. Okay, so for practice 2A, all right, I've got the angles in both degrees and radians. And so either from the notes that you've been taking or from those two triangles, I want you to go ahead and fill those out. So like the sine of 30 degrees, again, opposite over hypotenuse, so it'd be 1/2. Okay? So go ahead and fill those out. All right. So anyone having any questions on any of those? Anyone would like me to go through finding it or writing it down? Okay, so let's go on to the back side here. So now we're going to do evaluate trig functions with a calculator. So if you don't have your calculator handy, you might want to grab that real quick. But before using a calculator to evaluate a given trigonometric expression, you need to determine whether the angle in the expression is measured in degrees or radians. Then put the calculator in the appropriate mode first, because if you're in the wrong mode, you'll get the wrong answer. Okay? Now, a lot of times when we're doing word problems, you're going to see, for example, most of our angles in applications are going to be in degrees. All right? But then if you go on in calculus, most of the angles where the calculus formulas are derived are in radians. Okay? So when I taught all day at Holbrook High School and I had a classroom set of calculators, it was a constant battle because all the trig students would usually switch it to degree mode and the calculus students would switch it to radian mode. And if students weren't careful on tests, I remember I had a student that actually failed a test just because they didn't change the mode or didn't change back and forth. as they need to. So that's, you got to watch out for that. Okay. So for example, if so we're going to use the calculator to do the trig functions that aren't on those special formulas. So for example, if I ask you what's the sine of 45 degrees, I want radical 2 over 2. That's an exact value. Okay? But if it's one that we don't know the exact value for, we're going to use the calculator. Okay? Or some other tricks we're going to learn. So what we do, so let's say we want the cosine of 28 degrees. And you might just kind of follow along here just to make sure that you're okay. So you want to make sure you're in degree mode. And then you just type in cosine 28. So you don't have to do the degree symbol if you're already in degree mode. And then you press enter, and then, give me the answer to 3 decimal places. Okay? Now, the trickier ones are the reciprocal identities. So like secant is the reciprocal of the cosine. There's no secant key on your calculator. So what you have to do, in fact, is type in 1 divided by the cosine of 28 and then enter. Okay? So again, you've got to know that secant is the reciprocal of the cosine, cosecant reciprocal of sine, and of course cotangent is reciprocal of tangent. Okay? All right. So go ahead and do practice 2B. All right, so Hannah, when you've got A.
I
know what to do.
It's angle.
0.710663.
Okay? So rounded to 3 decimals, 0.711.
Oh,
Okay? Now, if you carry it out a little farther, that's fine.
I was right. 31 of these. This one. 36.
All right, Tara, the second one, B.
What? This will be.
No, it's not. It's okay.
I got 0.999.
Oh, little small.
So how about negative? Did you have a negative?
Why is it negative?
No.
Why is it negative?
Okay, so let's check. So if there's no symbol here, is that degrees or radians?
Oh.
Radian.
That's
Okay.
radian. So you need to be in a radian mode.
Oh my God! Tricked me.
Yeah, I did trick you on that one.
Oh.
Okay? But I'd rather trick you now than on a test, right? So if there's no symbol, it's assumed to be radians. So you have to be in radian mode. All right. So Tara, did you get the negative? 0.990?
Yeah.
Okay, awesome. All right, and then the third one. Third one's a little tricky too. All right, Hannah, that's you again.
Is it like 3 different answers?
No, there's just one answer.
Oh.
We should all have the same exact answer. As a matter of fact, that's what I love about math. It's not like English where we can interpret the author's feelings a different way. Who does that? No, math, there's one answer. All right, so Hannah, when you've got it. So part of what I'm testing here is to see if you remember how to put in degrees, minutes, seconds. Okay, you don't remember? Okay, a little hint, you got to use the angle menu. Okay. All right, so Hannah, did you get it? Or need help?
DMS.
What?
1.765.
1.765. There we go. Great job. And so this is how you have to enter it in, because cosecant is the reciprocal of the sine. So it's 1 divided by the sine of 34 degrees, 30 minutes, 36 seconds.
Can
Okay?
you work through it?
Sure.
Thank you.
Yeah, let's see. Let me grab that calculator. Okay. So, again, because it's cosecant, that's the reciprocal of the sine. Whoops. Okay. So that's the reciprocal of the sine. So you do 1 divided by the sine. Oh, you know what? I didn't check. See, I'm putting this in degrees. So I need to check to make sure I'm in degree mode. Okay? So mode, okay, I'm in degrees, so that's fine. Okay, so 1 divided by the sine. Okay, so now 34 degrees. So 34. So the angle menu is second, apps. So angle, and then the degree symbol is first. 30 minutes. So 30. Again, angle menu. And then the minutes, the second option. And then 36. And then the seconds is alpha plus to get the double tick marks. Okay, so alpha plus, and then press enter, and then boom. Okay? Any questions? Okay. You need to practice these skills. Okay? as we're going through, you need to practice or you're going to lose it. You're going to forget how I've taught you, whatever. I mean, it's not super hard, but you need to practice. Okay. Okay, so now we're going to go on to really, I think the most important part of this is the application problems. Okay, because trig is used all the time, from surveying to construction to whatever, and trying to figure out the different angles. Okay, so first of all, let me kind of give you a little preliminary thing. Is that when we're trying to solve a trig problem, you want to draw a triangle. That's kind of most of the problems we're going to have right away are going to be right triangle problems. So you want to draw a right triangle, and then the unknown, the thing that you're looking for, you label that x, okay, or whatever variable, and your angle and so on. Then what you've got to do is figure out what trig function you use. Okay, so let's say you've got your problem and you've got it set up this way. So with this angle in mind, what trig function is going to relate the side that you know and the side that you don't know? What trig function would relate these two sides in reference to that angle?
Cosine?
Cosine, because this side is the adjacent side and this is the hypotenuse. So the trig function, so you got to know that SOHCAHTOA like the back of your hand. Okay, well, you could write it on the back of your hand. But anyway, so sine is opposite over hypotenuse. Cosine is the adjacent over hypotenuse. So we need cosine. So then we set it up and say the cosine of 75 degrees is x over 40, opposite, adjacent over hypotenuse. Okay, and then to solve that, here let's I don't want this right here. Okay, so how do I solve this for x?
You multiply by 40.
You multiply by 40. Now, one thing that you might want to do for most of these is actually think of it as a proportion and think of it as like cross multiplying. Because sometimes you might have something else there, or the x might be on the bottom or something like that. So if you cross multiply, then you get 40 times the cosine of 75 degrees is equal to x. And so you just plug that in your calculator and boom. Okay? So that's kind of the setup. That's the algebra skills that we need. All right? So now let's actually go to a problem, an example. See which one I want. Okay. So if the problem ever says solve the right triangle, that means we need to find all the missing information. So if it just says find the height of this tree or something like that, then that's great. But if it says solve the triangle, that means you got to find all the sides, all the angles. Okay? Also, a couple of things. Angle of elevation, if it ever uses that, then that's the angle measured up from the horizon. Okay? So if you see a plane flying over, the angle of elevation is the angle from the horizon, you looking up to the plane. Okay, the angle of depression is measured down. So the pilot, as he looks down and sees you, then the angle down is going to be the angle of depression. Okay? Now, so how do I know these angles are the same? How do I know that they're equal? Okay, I need some.
Alternate interior angles.
Oh my gosh, that is amazing. I'm telling you, you should go tell Miss Yazzie that you totally impressed me today with your geometry knowledge. Okay? I think you have your little thinking cap on today and you're just doing great. Okay? So, yeah, alternate interior angles, you guys. Alternate interior angles. Okay? That's why they're congruent. So, sometimes your triangle, see, might be, let's see. So your triangle might be like down here, but you're given this angle. And so that would be the same as the angle in the triangle because of alternate interior angles. Okay? Excellent. Okay, so you remember the story about George Washington and the cherry tree, right? That he goes and he chops down the cherry tree. Well, so here's George over here, and this is a big cherry tree, okay? It's huge. All right, so let's say George measures the angle to the top of the tree 71.5 degrees. All right? And his distance from the base of the tree is 50 feet. And he wants to calculate the height of the tree. All right? So what trig function is going to relate the side that we know of this triangle to the side we're looking for, which is the height of the tree?
Tangent?
Tangent. Excellent. Excellent. Okay. So to find the height of the tree, we would use the tangent. Okay. So the tangent of the angle, 71.5, would be opposite over adjacent. So I'm using x as the height of the tree, 50 is the distance. So opposite over adjacent. Okay? So then to solve for x, cross multiply, or here you could just multiply by 50. And so that's what you would put in your calculator to get the answer. Okay? So the height of the tree, over 149 feet. That's the largest cherry tree you've ever heard of. And I'm not telling a lie here. Okay? Any questions? Okay, so go ahead and try practice 3A. Speaking of George Washington. And here I want you to round it to the nearest foot. All right, so Sari, when you've got it.
I'm not really sure how.
Something Danny DeVito.
Okay, how to set it up? Okay. So here's my triangle here. So I'm trying to find the height of the Washington Monument. Okay. So here I have the angle, and it says the surveyor measures the angle 78.3 and is 115 feet from the base. So this would be 115, this would be 78.3, and I'm looking for the height. Okay, so what trig function is going to relate the side that you know and the side that you're looking for? Kinsley, you look like you're about to say something smart. Yeah, somebody needs to unmute her.
Sorry, we had an announcement, so I didn't want to.
Oh, okay, thank you.
But I believe it's a tangent.
Tangent, okay, very good. So you do the tangent again. So you say the tangent of 78.3 degrees, that's the opposite over the adjacent, so that's y over 115. Okay? So then to solve it, you're going to multiply 115 times the tangent of 78.3 and put that in your calculator. Okay? So Sari, go ahead and put that in your calculator and tell me what you get.
I got 555.
555. Okay? So rounded to the nearest foot, 555 feet. Okay? Very good. Any questions on that? All right. Good deal. Okay, so the question you need to ask yourself when you're doing these problems, and if you notice I ask it every time, is what trig function do you need to solve for what? Because sometimes it's sine, sometimes it's cosine, sometimes it's tangent. Okay, it's not always going to be the same thing. So when you draw your triangle, you need to ask yourself that. What trig function do you need to find what it is that you're looking for? Okay. All right. So in this example, let's say Skater Joe here wants to build a skateboard ramp. Okay. Now, if you've done much skateboarding, it's really nice when this ramp has as few it's really nice if you could make this out of one piece of wood. Because anytime you have some kind of connection or whatever, where the wood comes together, it could be dangerous if that starts to separate a little bit. So what he does, he says, okay, I want the angle to be 18.4 degrees. And you might say, well, why? Well, sometimes there's just weird specifications, okay? And he wants the height to be 4 feet. And so he wants to know, okay, he's going to go to Waltz and get a piece of lumber, and he wants to have it cut exactly, so he doesn't have to splice two pieces together. And so here, he knows the opposite side, but he's looking for the hypotenuse. So you say opposite over hypotenuse. So this one's going to be cosine. The other thing that's different about this one is the variable is in the denominator. Okay, so don't let that trick you. When you cross multiply, it'll just become c times the sine of 18.4. And so now to solve for c, you're going to divide by the 18.4. And so algebraically, it's just a little bit different, but you still can get the answer. All right, so go ahead and try practice 3B. All right, so Madison, when you've got it.
I got 15.84 feet.
15.848.
Then that would be 15.
I did this at 8.
Wait, what are we doing?
15.84.
Oh, I was right.
Okay.
feet.
You got 840. So I know this sounds crazy, but like there was one time when I was working at the University of South Carolina, and they spent $5,000 making a handicap access ramp. Okay, now that's not crazy because we need that because the school just had stairs, right? So you need to have some kind of a wheelchair access. All right, but the thing that was crazy is that so their angle that they put on it was like 20 degrees. And then they made this in cement. And so somebody comes along from OSHA or whatever, I don't know what government agency, and they're like, no, it's like a half a degree too steep. And they had to tear it all down and redo it. So $5,000 wasted, okay? Because somebody didn't check their math, okay? So anyway, so sometimes these angles, they've got to be exact, especially, when you're working in business or whatever. So loading ramp, that could be one. All right. So this last example, that what we're going to do is actually show you how, like you might have wondered, how do they determine how tall a mountain is? You ever wondered that? See, because you can't like do a triangle, like you can't like say I'm so many feet from the base because you can't walk to the base. So what you actually do is you take two different readings. And so you make two different triangles. So you measure to the top of the mountain and then you walk backward and then you measure it again. And and you can figure out, okay, I'm walking backward. And so then when you measure it again, using triangles and a formula, I'm not going to go through the whole thing, but you can calculate then what the height of this triangle would be, even though physically you can't enter in the middle of the mountain. Okay? So this example is Mount Baldy in Arizona. Okay? So to find the height of an object given the angle of elevation from 2 points, you use the formula. Okay, so the height is the distance that you walk back divided by the cotangent of the second angle minus the cotangent of the first angle. Okay, so you need to write that down. That's kind of not in your book very clearly. So the height is the distance divided by the cotangent of beta minus the cotangent of alpha. Now, okay, when you're doing the angles, okay, if you're not sure which one's alpha and which one's beta, it doesn't really matter, because if you subtract it wrong, you'll get a negative answer, and it can't be negative because you're talking about the height of something. So don't sweat that. So if you just end up with a negative answer, take the absolute value, okay, make it positive. All right. So in this one, see, what I would do is I would actually do the cotangents first. So the cotangent, remember, you do 1 divided by the tangent. So I actually calculate the cotangents first, and then I put it in. So I've walked back 1,000 feet. I put in the cotangents and subtract. And so then Mount Baldy is 10,405.83 feet high. Okay. All right. Well, let's see if you can apply that to the practice 3.
Mr. Strong, I have one question.
Sure.
On the calculator, there's sine, and then there's like sine -1, the inverse of sine. That's not the same as.
That's not the same thing. We're going to actually do that like in later in this chapter.
Okay, got it. Thanks.
Okay. All right, so Sierra, whenever you've got the answer, or if you get stuck, let me know.
I need help on this problem.
Okay, so what you want to do is, so this is the formula. So the angles are in degrees, so make sure you're in degree mode. All right, so the way I do it is calculate the cotangents first to put in the formula. So 1 divided by the tangent of 19 and 1 divided by the tangent of 9. All right? Then I plug that into the calculator. Now the distance, it says, is 68.2. So I'm going to plug that in as well. So the height is going to be 68.2 divided by, and then let's see, I don't know why I'm rounding here. So 6.314 minus 2.904. And so does anybody have the final answer?
20 feet.
20 meters, actually. Okay. All right, good job. So 20